So a little explanation on this. The idea was initially that we'd have the customer here, but there was some family things that came up, one of which was the speaker having a baby. So fair enough, right? So what we wanted to turn this into as a second best offer is I brought in my friend Aless here, who works very closely with the customer, has intimate knowledge with what they're doing, their solution, and was also at KubeCon a couple weeks ago. Anybody here was at KubeCon in the States? Couple? Okay. This talk was given there together with another colleague from DoorDash, and is recorded if you want to take a look at it. But we thought it'd be nice to bring this over here and share it with you, because it's a really interesting story. So let's kick this off so we can get back on track. My name is Eric D. Schabell. I work with Chronosphere as the Director of Evangelism, and this is Aless. He's one of our sales engineers who works very closely with DoorDash, among other customers. So it should be really, really interesting insights into what's going on. Go ahead and hit the next one. So how many people here know what a data point is? And this is more a check just to see if you're awake, right? Any hands going up? Yeah. So there's a little metaphor here just to build the story up to understand where we're coming from, right? So it's kind of nice that you think about out there somewhere are flowers, and there's a way to get to these data points in a timely fashion, to scrape them, to bring that back to next, to bring that all the way back to, and next again, to the hive where we're collecting all these things like bees, right? This is Prometheus in a nutshell, right? It's not really exciting, other than that you have to think about the data at the endpoints being most valuable when it's fresh and less valuable when it gets really old. And there might be some disagreement from the presentation that you saw previously where they're talking about the out-of-order data, where you want to go back and aggregate and look at some of that old data. Then it has value again. But ideally, we want to be able to collect this data as fresh as possible, get it into our systems, and deal with this. This is all fine when we're talking about one instance of scraping, but when it starts getting into the thousands, the 10,000s, or even hundreds of thousands of scraping points, it gets really interesting how this goes. There's a couple of ways to look at it, and that's what this talk is about. First, you start out with centralized, right? You have something very big, centralized, it's scraping. The upside is it's easy to configure, easy to manage. The downside is that it's expensive. Look how big this is, right? This is a big, expensive endpoint. So when he's gathering all this stuff, what happens when it breaks? The whole operation stops. So then we go to the next one. We think, oh, let's try this one. We'll go decentralized. Anybody know what this is, this picture? See how old you are. It's basically any game you're looking at on your phone or your kids are looking at right now too. Same idea. You send out little collectors, right? They go out and they start collecting remotely for you. Not a problem. Small, cheap. They can go down. You just go back and get them again, start them back up, and off they go. It's a really nice way to collect. Then we go to the next one. But what about when you're trying to do the most optimized for your hybrid environment? So maybe you want to do some of it centralized, you want to do some of it decentralized. What's that going to look like? Anybody tried that yet? You start doing that at scale, it starts getting really complicated with what you're doing, and that's what we're going to look at today. But trust me, I'm going to turn it over to Aless, because you can do this. You can achieve what you want to do with a hybrid scale. So with that, I'll give it to Aless, and I'll become the clicker for you.
This works. Or maybe now it does. Thank you very much. Hi, my name's Aless. Thanks for the intro, Eric. So, as promised, I'll talk a little bit about a hybrid approach to centralized and decentralized scraping in the context of a company that I work with pretty closely, and that's DoorDash. I'm pretty sure most people have heard about DoorDash. They're pretty popular, as my co-speaker at KubeCon said, and for people to have an idea, like I'll share some numbers from 2021. They delivered 1.4 billion orders in a year by 6.3 million dashers, meaning the people who actually do the delivery. So they're like an or last mile logistics company, right? For businesses of pretty much any size out there. Now, obviously, to run an infra that size, things get pretty interesting. They're heavily Kubernetes based. They're running more than 20 clusters, and the biggest cluster they have is at peak almost 2,000 nodes. And that's about 35,000 active pods in those point in time. Now, if you start thinking back from this, it's like, whoa, what do you do for observability in an environment like that? It must be pretty interesting, right? And lo and behold, they're using Prometheus metrics. They used to use statsd metrics, and they're not anymore because, well, it didn't work out too well, and I'll get into that a little bit later. Anyway, it was a long and arduous migration, upwards of a year to kind of get things into Prometheus. And so how does that look in Prometheus? Well, they pretty much have a ballpark, 100,000 or more scrape endpoints that collect about 10 million data points per second. Yeah, and all of that gets shipped and processed. And out of that data, they obviously keep it actionable. They run tens of thousands of alerts on them, most of them with 1 minute intervals, a bunch with less. So you kind of know the scale of the matter. So with that, we can, wait, why did it skip to? OK. We can actually dig into how the environment is built a little bit more. As you can see, it's very heterogeneous, right? That you have a lot of different things. And I'll walk you through this in brief and then kind of dig into these models a little bit more. So first of all, I said before, they're Kubernetes-based. And what they do for Kubernetes, for the most part, is deploy the decentralized collectors. So they do this, well, they use Chronosphere to store their data. And they use a collector that is essentially like the Prometheus collector or Prometheus in agent mode in its essence. Only it's called the Chrono Collector. And you can deploy it in many different ways. So one of the ways how you can deploy it is a DaemonSet. So they deploy the DaemonSet into their clusters. So you essentially get, well, a few thousand collectors that kind of do this for you. The good thing about it is it'll scope scraping only on the node to where it's actually deployed. So you automatically just spread around your environment, and you don't have to deal with breaking up. I mean, how do you separate what each of them scrapes? Then the other thing that kind of hits us here is, well, there's also some legacy stuff that runs in EC2 instances that is not Kubernetes deployed and uses file-based discovery. It's quite simple, and you can configure it for each instance separately. And then there's also a bunch of other non-Kubernetes workloads that are also collected by the kernel collector. And that's mostly outside workloads, meaning how do you collect CloudWatch? How do you collect metrics from another, like a third-party vendor that you want to still have in the same data store? Because that's what for the most part on their end the users want. It's like we don't want to have multiple data stores and kind of go between things. So they want to store everything in one place. Excellent. Well, let's go to the next one. Thank you. So let's talk about the models a little bit more. First of all, yeah, obviously the DaemonSet. For all of the microservices workloads that they run, they pretty much do this. And maybe to just start in the beginning, they didn't get to this point just from the get-go. They didn't architect it this way. But when they were doing the migration, they figured out that there's certain things that are better this way and other things that are better that way. And just to make things work reliably and cost effectively, they came up with multiple approaches to make this happen, right? Now, on the DaemonSet side, it's actually interesting because through the migration, where they kind of said, well, we're going to do this team by team, and with that, figure out kind of how do we best approach this on a global scale. They came up with best practices, and one of the best practices was that you want to have enrichment of the data, or actually standard labels stacked onto the data at the point of collection, right? And at the same time, do the rewrite rules on that front. And that actually takes away a lot of the burden that you have to put on the teams that generate the data, because it's kind of done centrally. Then the next model, sidecar. So why would you sidecar a collector if you could actually do it how I described before with a DaemonSet? Well, you'll have special cases, special services that are either a lot bigger, require more resources, do weird things periodically, and you just want to, they're noisy neighbors, and you kind of want to move them away. So usually do that with a sidecar. Then they run Unix services for some of their collectors because they are EC2 machines, and they're totally separate from the whole environment. So it's a little bit different. And then the Kubernetes deployment, another separate case where they actually collect data from CloudWatch stuff, third-party vendors. That still runs in Kubernetes, but runs as deployment because they run one or a few pretty large instances of the collector to get that done. So that's how kind of the ecosystem looks like. Thanks. So what's really important in this whole situation, like from them, while doing this migration and running this at the scales that I described over the past couple of years, they figured out that the stability of the collection infra is extremely important, because if things go down or things don't perform the way they want them, it gets messy, right? So they want to ensure the reliable collection of metrics. And since the deployment is pretty large, every change has knock-on effects through the system. So they are very careful with how they roll those changes in. Another important piece was discovery. When obviously people who develop code create instrumentation, they push their code, they want this to be very fast, meaning that new endpoints get discovered, scraped, and data is available in the product. Otherwise, the end users get kind of unhappy. Then the next part, a big lesson, was the data enrichment piece that I already mentioned before. Essentially putting standardized labeling in place to avoid any sort of mishaps like they have occurred before, where people changed the order of how things were kind of named in Graphite, and then all of a sudden you cannot scrape things in this, or kind of query things in a standardized way. That kind of goes away with the enrichment piece, where you put standard rewrite rules on everything, or standard labels on everything that gets collected through this infrastructure. The next big piece was also the rewrite rules. Those are also standardized through the whole collection infra. And if things are done centrally at scale, they found that the rewrite rules can actually have a pretty big hit on performance, which is undesirable. But with the decentralized collection, because you have so many workers that are fairly small and efficient, that does not put any delays into the process, or put a lot of load onto the workers. And there's also one thing that became important through the process as the organization started relying on SLOs a lot more, and those were the recording rules. So they have a lot of them. Because all the SLO dashboards are actually powered by the data that's actually coming from the recording rules. Out of this, some of the pros of the whole implementation. Starting things off, there's no single point of failure. Most of these things, like if you look at the distributed or decentralized collection infra, as Eric said before, you have a lot of small things that do their job, that if they go down, you can quickly reboot them. If whatever happens to them, it's one out of many, so you're only losing a small portion of data. So the decentralized nature of the deployment is actually really beneficial from that perspective. It scales really well. Why? I mean, if you add new nodes into a cluster, it automatically gets new collectors added to the cluster, right? And those nodes, kind of, if you figure out where the resources need to be, it's just going to work out of the box. Also scales well from a perspective of all the rewrite stuff that needs to run, and they also tell us that they like the aspect of scalability from a perspective, how much data they produce, and kind of where does that end up, which is in Chronosphere, so that they don't have to deal with that on their end. Quite flexible. Once you have the whole situation figured out with how discovery works, how people actually put new services in, they just deploy it, and when it's deployed, it'll find the targets and data appears. Yeah, the recording rules that they run, a serious amount of them, there's no noticeable performance impact of the whole thing. So they because of that, even more started relying on SLOs to make things happen. And yeah, there's no noisy neighbors, right? Because things are split apart so much. You're not going to have a situation where one service, explodes its data and kind of makes everybody else lose the data as well at the same time. Now, it's obviously not all roses. There's also some lessons that also came out of this from a perspective of what are the downsides. So it's pretty heavy on resource usage, mostly from the perspective that you are running so many units that actually collect data. And that's not even such a big problem because the collectors themselves, they run pretty lean. Like, yeah, obviously you have thousands, but for the most part, they'll use a fraction of a core and run somewhere, sub 100 to 200 megs of memory, most of them. But you'll have situations where you have a large node, or there's a service that produces more data, so maybe it needs a little bit more. But that means that you need to actually scale the whole deployment or set limits for the whole deployment to match that highest use case. That's also one of the reasons why for some things you'll have sidecars. So you can actually take them out. There's also strategies on how you can oversubscribe the nodes to some extent so that you can optimize resource usage, but there's still a little bit more of it. Then the whole situation with how do you keep this, how do you maintain this? Well, there are daemons that deploys, but you have thousands of units in them, meaning, yes, you can change only one thing and roll it out, but you have to be quite careful. They've come to find out that it's usually better to roll out deploys pretty slowly. So sometimes when you do this, it might take a day or a little bit longer to get it done, and you have to keep an eye on it. Also, when you manage this for a bunch of clusters, well, that means you have to repeat it a number of times. There's a bunch of automation that you can do to make that a little bit easier on yourself, but it's still an operational burden to a degree. And with that many collectors being run, it gets a little bit tricky. How do you debug things? Just because you need to find it. Well, the collectors themselves are pretty good at it because they will expose metrics for themselves that you can alert on, and so on and so on. So detecting issues is quite possible, but still you need to deal with it. And then collecting debugging information from them is a bit of a chore, right? Because you have to connect to something, get the data, analyze it, figure it out, and go from there. Yeah. So out of this whole process, some final thoughts. The whole approach to distributed architecture from their learnings was that it kind of becomes a necessity. How they've done things before with StatsD Graphite is that things started, well, to not work really well at about 1 million data points. They started losing data or seeing some knock-on effects of their growth. Admittedly, there may be some optimization that could be done, but the approach they took kind of solved those issues. Like there's hardly any data loss. Things are kind of working how they need to work. And the whole distributed approach works really well with Kubernetes. It's well suited to do the deployment of the collection infra the same way that you do deployment of your services. And, the DaemonSet approach actually works really well in this situation. Bit of a negative side, there will be exceptions, and you need to simply work through them and figure out the best way on how to approach each workload. Yes, predominantly you can distribute your collection, but there's always some things that you'll find that are better than this or the other way. The whole infra, once you work out the kinks and you figure out what are the best approaches to use and how to do it, is very stable. When talking to Rabun, who's kind of one of the people who worked on this on their end, he's like, yeah, once you have it up and running, you hardly ever need to do anything. It'll scale up and down with the infra, and you simply track and leverage the data that's actually giving you. There's obviously a bit of a penalty there with the usage, the higher usage of resources that are needed to get this done. Now, that was a quick overview of what DoorDash has done with their observability stack, especially on the metrics side. And that kind of concludes our talk. So if there's any questions, we're happy to try to answer them now. Yeah, otherwise also come find us after on the social thing after the talks.
All right. Thank you very much. Any questions on that one? No questions? All right, then. Going once, going twice. Thank you very much.